What happens when data grows and grows and grows? One of the biggest surprises when it comes to databases is how dynamic it all is, and not just in one way, but in fact, many ways things will change to your astonishment. Well, how about an example? I worked on a contract that started back in 2001. We were building a nationwide communications network, working with all the various telecommunications providers, big and small. And this required that we monitor all the equipment at all the sites so we could detect an outage. The rollout on that contract was to start with 22 sites. 22 sites with a couple hundred services is hardly anything at all, and that's a good thing. We needed to get warmed up on building these services as well as monitoring them. We worked out what the various entity types were and how they were related to each other. What's a device? What's a card? Does every device even have cards? No? Okay. What about ports? Some alarms are reported at the device level, some at the port level. Some devices have ports and some have cards that have their own ports. It took a few months, but we had something operational, and this included writing a fistful of queries so the monitoring application that I was responsible for could see an incoming SNMP alarm and correlate it with the device that had failed. We'd open a ticket and alert the operations staff so they could then start their process for effecting repairs. The part that's not mentioned in this example is that 22 sites with a couple hundred devices would eventually scale over the next 2 years to 8,000 sites with closer to 300,000 devices. At that point in time, queries I had written 2 years earlier didn't scale. Hear that one again. Queries I had written 2 years ago didn't scale. What's a real-world instance where something that worked at first failed later? Hostname resolution is considered case insensitive. Every alarm that flowed into our system included a hostname, but the case was mixed. Some would be all caps, some lowercase, but the table that contained all the hostnames only had one entry for that device. So we said early on, just apply an upper function on each side when you apply a query filter. And yes, that solved the problem. Any hostname on the alarm would properly match the hostname in the related table. What we didn't know was that using an upper function was causing us to sidestep the index. The hostnames were indexed, but not the uppercase version of the hostnames. Hence, every query that we did resulted in a full table scan. Now, if you're confused a little bit by this, go back and rewatch What is an Index if you need a refresher. A table that grows from 200 entries to 300,000 entries results in a 1,500x increase in cost. Those queries may have been sub-second when I first wrote them, but now they were taking seconds. To further compound the problem, not only did the queries take longer to run due to the roughly 1,500x increase in equipment, but the volume of alarm data that flowed into the data center increased by a similar amount. So imagine a 1,500x increase multiplied by a 1,500x increase in traffic that has to be correlated that way. Back of the envelope calculation will show that this is a 1,000,000-fold increase in cost. My queries from 2 years earlier did not scale. Thankfully, that team had a devoted database administrator assigned to us. He helped us analyze and rewrite queries, and he taught me so much. The most valuable being how to use explain plan to grok what the database is up to for a given query. Every database comes with a certain version of explain plan. However, it's not a standard, so they're all different. But fundamentally, you type explain and your SQL statement, and the database engine spits out an analysis of your query instead of the results. Some will do both. And that report will typically show you what the engine did first, how many rows it took to do it, whether or not indexes were used, and how many rows of every phase were involved. The query I mentioned earlier reported multiple full table scans. And as mentioned in What is an Index video, full table scans are bad. So I got to work. I had to rewrite multiple queries. I had to consider not just that aspect of case insensitivity, but also the relationship between various tables. Some tables may have a one-to-many relationship, but if the many table in that situation has only like 4 rows because it represents an enumerated constant that won't be changing much over time, then there's little to be gained in optimizing that join. However, two tables that each have hundreds of thousands of rows and are also in a one-to-one relationship may require more attention. That's why it's vital to find out which queries are eating up the database engine's time the most and focus on them first. I've seen database engines that have something called Top SQL, a tool like Top that'll show you which queries are eating up the most time. I had learned of Top SQL because that contract reached a point where a few years later, the database was hitting 100% CPU utilization on a daily basis around noon. They had assembled a strategic team to define what was happening and how to deal with it. Now, I was not part of that team, but happened to be walking by one of their meetings and peeked at the overhead. They were focused on query number 1. I spotted that query number 2 was mine, and from a different application that had nothing to do with network monitoring. I asked some questions and realized that a business office application that wasn't, quote, mission critical was in fact incredibly inefficient and eating up ridiculous amounts of CPU time. The original developer of that app had rolled off the contract and I had inherited his app. I dug in and uncovered a query that took 20 minutes to run. Yeah, that's right, 20 minutes. This app had been out there for years to help the business office provision news sites. But because it wasn't, quote, mission critical, it had received little priority. I found the query that was eating up so many resources and I ran it through Explain Plan. And I discovered that it was joining the same table 20 times. Yeah, 20 times. Not because there was a semantic reason to. Nope. The query was grabbing various views that had parts of information the application needed and stitching it all together. In case you didn't know, reaching for someone else's database view is a big no-no for precisely this reason. Anytime you draw up a new query, you should start with joining the tables directly that you need to gather the information you require. This way, you're combining the real source of the data and hopefully only making the exact joins needed. Now, this application was so complex, it actually took me about 5 weeks to even figure out what this expensive query was doing. Suffice it to say, I finally figured out what it needed, rewrote the query to not use any views, and the query went sub-second. The team using that application had been used to clicking the save button and going for a coffee break. This time, they clicked save and it was done, and they didn't even realize it. Once they did, they were ecstatic. They even gave me a little piece of paper certificate award. Yes, these are a couple of war stories shared from my own experiences, but they're meant to convey a couple valuable points. Data changes over time. The volume of rows in various tables can change over time, hence causing performance issues that weren't there before. Some operations aren't even mission critical and can still eat up valuable resources. The landscape of query writing is quite dynamic, and so being able to stop building new features and instead dig in and analyze and perform updates to fix dragging queries is always a valuable skill. But it's not hard. Databases in SQL are quite approachable by any database user, which makes one ask, what is a database user?